Mobile devices are part of our everyday lives. Instead of using desktops and laptops, people now use their mobile phones and tablets for everyday tasks like shopping online or booking holidays. This type of activity has become much easier. This is because the mobile versions of websites now provide the same user experience as if you were using a mobile application. And this improvement is thanks to the push toward cross platform app development. Recall that cross-platform development produces a single application that can be deployed or used on multiple operating systems, such as iOS, Android, and Windows. There are multiple tools and technologies available, all of which have their roots in web development. In this video, you will learn about why cross-platform app development is important for teams building web and mobile applications. But first, it's helpful to understand why this came about. This began when it became possible for users to access the internet from a browser on their mobile device. The new preference to browse the web on mobile led to the development of mobile-friendly websites. These websites were a separate implementation of the standard or desktop website. Having two separate websites meant that it was time-consuming and expensive to produce web-based content. Then, in 2017, search engine results started prioritizing mobile-friendly websites. This was known as mobile-first indexing and led to the development of best practices for mobile-first design. Mobile-first indexing caused the rapid development of new technologies to ensure that desktop web content was easily accessible on a mobile device. And this led to the development of responsive websites. A responsive website can alter its layout, depending on the screen size it's being displayed on. The website content can automatically adjust based on the screen size or orientation of the device viewing it. However, responsive website developers also had to deal with the limitations of mobile devices in terms of memory and processing power. Another limitation is that all user interface or UI elements were provided by the website content rather than by any of the mobile device UI elements. While these websites performed well, they weren't quite the same across different platforms. There were differences in rendering, navigation, and user interface options. For example, a responsive website viewed on iOS may differ from a website viewed on an Android device. A better solution was needed. So, large organizations introduced dedicated mobile app versions of their websites that can be downloaded directly to user devices. However, this introduces a new problem. For development teams working on this mobile app development, they now had to consider the different operating systems. For example, if you wanted an app that worked on Android and iOS, then you needed to create two native apps. This meant that two development teams had to work on the same app using different code bases. As a result, the development cycle was longer and more costly. For example, the development teams had to create separate apps for Google Play for Android, the App Store for iOS, and the Microsoft Store for Windows Mobile. Separate development for separate platforms was not ideal, and multiple techniques were developed to address the problem. The first solution was web apps that could be installed on a device but could still deliver their content over the network. However, these apps couldn't be installed in the same way as native or platform-specific apps. Instead, they existed inside the browser and still required an internet connection to function. Although web apps could use some of the functionality of the device they were accessed on, they depended on a web browser. Because of this, the experience could be different depending on the browser used. One is a Progressive Web App, or PWA. This allows for greater integration with the device. PWAs can be installed on multiple types of devices, and they can access most of the built-in features of the device. However, PWAs still use web technologies and require the browser's engine to run. Another solution is cross-platform application development. Recall that cross-platform developers make software applications that are compatible with multiple operating systems. The development of this specific technology has led to a number of options. One of these options is React Native. Recall that React is a JavaScript library that is primarily used to build websites and user interfaces. React, combined with the use of React Native framework, allows for the development of cross-platform apps. Using a single code base, developers can make apps that work on web and mobile devices regardless of the operating system. These apps can access device hardware as well as use the native or built-in operating system UI elements. This type of software development allows for the user experience of the app to be maintained regardless of the platform used. In summary, cross-platform development provides a way to access hardware or operating system-specific components through a common developmental approach using a single codebase like React.js and React Native. This has streamlined the mobile software development cycle and made it easier and more cost-effective to create apps that work the same across different devices. There have been many instances in which developers have reached the end of a project only to realize that a quicker or easier method could have been used. That's why it's important that developers know the pros and cons of their development process. With a cross-platform development process, for example, there are many advantages and disadvantages to be aware of. Over the next few minutes, you'll learn how to identify the advantages of cross-platform app development and be able to identify the disadvantages. One of the many benefits of cross-platform development is that you only need to learn one language to have the ability to create applications for multiple platforms. Another effect of cross-platform development is the decrease in project costs. Let's begin by exploring the methods that lead to this cost reduction. Only one development team is required, which significantly reduces cost. And apps can move to market quicker because they take less time to develop. Apps are developed using the one common language, which also reduces required resources. There's no need to write unique code for both iOS and Android. The same code can be used for multiple platforms. Bug fixes for code only need to happen once, and the use of common development tools across platforms also leads to a more uniform and seamless user experience. Another key advantage of cross-platform development concerns the marketing efforts required to launch an app. Cross-platform apps only require one marketing campaign, but native apps require a separate campaign for the users of each platform. Apps developed for multiple platforms can launch across all operating systems on the same date with maximum exposure. And a unified release date means that all users can be reached at the same time. Cross-platform development also makes things easier after initial app development has completed. For example, cross-platform development means that you can synchronize maintenance. So you only need one update for both platforms. And the increase of bring your own device, or BYOD culture, means workplaces can increase the early adoption of work apps. As you've just discovered, there are a lot of advantages to cross-platform development, but this approach also comes with its disadvantages. Let's take a few moments to explore some of these. An app built for multiple platforms might mean the exclusion of some platform-specific features that a native app could take advantage of because a common code base must be used. The use of advanced features might negatively impact battery life and other system resources. And integrating with platform-specific and user-specific local settings, preferences, storage, and notifications can be a time-consuming effort. These types of issues can lead to a lower quality user experience on each platform. If you were to avoid a cross-platform approach and develop using each platform's defined native code base, then you could utilize all its features and focus more on UI and UX design. Developing specifically for a particular platform means that you don't reach the user base of other platforms with your app. However, your app may work better on the chosen platform and provide a superior user experience. You can now identify the advantages and disadvantages of cross-platform app development. Great work. Make sure you use this new knowledge to help you improve your development process. To emulate something is to copy or imitate it. For example, you listen to your favorite band and they play a song from another band or artist. You might also be familiar with retro gaming. This is the process of emulating or imitating a classic video game console, allowing you to play it on a modern computer or device. Emulation also exists in software development for developers building web and mobile apps. Here, an emulator is a piece of hardware or software that enables one computer system to imitate another. This gives the host computer the ability to run software or devices designed for the emulated system. By the end of this video, you will know what an emulator is and how they work for mobile app development. Emulation is a fundamental computer principle with a long history. While mobile apps are consumed on mobile devices, developers build these apps by coding on computers. To test the code, developers need a way to emulate mobile operating systems like iOS and Android. Mobile emulators use the existing computer hardware to replicate the environment needed to execute iOS or Android. The emulator provides access to any required system-level capability to replicate the mobile device, including the amount of RAM or working memory, the processor type and speed, the screen size and resolution, and the amount of local file storage available. Emulators save the development team time and money by allowing them to implement different test environments that reliably replicate the end user's devices. Much of the initial testing is carried out on the emulated device, especially for developers building cross-platform apps. While emulators are a powerful solution, they do have some limitations. For example, while you can emulate the iOS environment on a PC, even the best programs cannot emulate some aspects of the native mobile environment. Emulators can also put a bigger strain on resources such as the processor, RAM, battery, and storage. The size of the app will also be bigger, with a larger code footprint overall, making the functioning of the app slightly slower than true native. As a result, it's standard practice for developers to test apps on both the emulated environment and physical devices whenever possible. However, because there are so many different devices on the market, testing on them is not always viable, and emulation is preferred if the app will be deployed to a platform like the App Store or Google Play. Okay, let me introduce you to some emulator examples now. Typically, a cross-platform framework will include an emulator or suggest one to use. Developers can use platform-specific emulators like Android Studio for Android and Xcode for iOS, or even online emulation services like Appetize.io. Finally, let's look at an example of an emulator in action. With this particular emulator, the mobile device is replicated to a high level of accuracy and performs with the full functionality of the real-life device. You will learn more about emulators later. In this video, you learned about emulators and how developers can use them to help create mobile applications. They provide a fast and effective way to preview your app during development.
I'm sure you've noticed that when you shop online, websites will often provide you with personalized recommendations, but when your friends log into those same websites, the recommendations will differ. But did you ever wonder how websites adapt to different user profiles? In this video, you will learn the difference between static and dynamic content. You will also be able to differentiate between the role of a web server and an application server. By now, you know that when you open a website, a web server sends the website's content to your browser. The content can be static or dynamic. Static content is files that the server transfers just as they are stored on the web server, such as videos or images. Dynamic content, on the other hand, is generated when the HTTP request is made. For example, the content may be generated based on input from a user, or when you visit a news website, it would be based on the current date. What actually happens is that the web server communicates with another kind of server, called an application server or a backend. The application server generates the dynamic content that the web server sends back to the user's browser. Now you know the difference, let's look at examples of how websites update static and dynamic content. Say, for instance, you want to watch a video on a website. You click on the play button and a request is sent to the web server. The web server responds by sending the file to your browser. Now, how does this compare to dynamic content? Because dynamic content is generated while you use a website, it typically takes longer to generate than it takes to send back static content. For example, when you log into this course, the web server communicates with an application server to check that you are in fact enrolled. The application server confirms your enrollment and specifies what content should show for your profile specifically. Application servers perform more complex processing than web servers. For instance, they have to run application logic, communicate with a database, and check permissions. To improve performance, different application servers have specific purposes. There are application servers for every type of content out there, from music streaming to creating your own blog. You can even create your own application servers, such as building a backend for a web application. But hang on, if dynamic content is slower to generate, isn't that a problem for big websites? Yes, it is. Application servers typically have a limited capacity on how many requests they can process per second. But fortunately, this is where the web server can help out. Web servers use a process called caching instead of generating content dynamically for every request. Caching means the web server keeps a copy of dynamic content. If the content is requested again, the web server can immediately send this cached version instead of passing the request again to the application server. On the first request for dynamic content, the web server checks if the content exists in the cache. If it does not exist, the content is requested from the application server and stored in the cache. The web server then sends back the dynamic content to the browser. On subsequent requests, the web server immediately sends back the content stored in the cache. This reduces the amount of dynamic content that the application server has to generate. Then, after a period of time or with the next user interaction, the web server updates the cache with the latest content. Now you know the difference between static and dynamic content, as well as the difference between web and application servers. With this new information, try to identify whether the content on the websites you visit is static or dynamic. Let's say that you're thinking of building a web app. You probably want a user-friendly, mobile-friendly experience. Then you should consider using single-page applications or SPAs to build a unique, speedy, and engaging experience for your users. You're probably using many SPAs every day. Think of your favorite social network or messaging app, or the map application you use to find local businesses. The great user experience you get is driven by single-page applications. So, what exactly is an SPA? How does it work? How is it different from a traditional website? Let's first explore how a traditional website works. Before the advent of modern JavaScript frameworks, most websites were implemented as multi-page applications. But this makes traditional applications resource-intensive to web servers, because sending entire web pages for every request consumes excessive bandwidth and uses CPU time to generate dynamic pages. If your website is complex, the site browsing experience may appear slow to users. It will be even slower if they have a poor or limited internet connection. To solve this problem, many web developers build their web applications as SPAs. It's called single page, but that doesn't mean your website has only one page of content. What it means is that there is only one HTML page that gets sent from the server to the browser. But that page will update its content as your users interact with your website. A SPA allows the user to interact with the website without the application needing to download entire new web pages. Instead, it rewrites the current web page as the user interacts with it. The result is a browsing experience that feels faster and more responsive to user input. When the user navigates to the web application in the browser, the web server returns the necessary resources to run the application. A SPA has two approaches to serving code and resources. The first is called bundling, and the second approach is known as lazy loading or code splitting. With bundling, when the browser requests the application, the server returns and loads all necessary HTML, CSS, and JavaScript immediately. With lazy loading, the browser requests the application, and the server returns only the minimum HTML, CSS, and JavaScript needed to load the application. Additional resources are downloaded as required, for example, when a user navigates a specific section of the application. Both approaches are valid. The choice depends on the size, complexity, and bandwidth requirements of the application. For instance, with the bundling approach, if your application is complex and has a lot of resources, your bundles will grow quite large and take a long time to download. You could end up with a site that is slower than a traditional web application. Let's explore an example. Imagine you have a site dedicated to reviewing movies. People never know what to watch next, so you decide to install a feature that randomly suggests the movie for a user. You create a web page that has a What to Watch Next button. You want to display a random movie name when the button is clicked. In a traditional website, when the button is clicked, the browser will send a POST request to the web server. The web server returns a new web page containing the button and movie name. The web browser then renders the new page. In an SPA, when the button is clicked, the browser will send a POST request to the web server. The web server will return a JSON object. The application reads the object and updates by displaying the text of the movie name. That's more efficient because the rest of the page remains as it was, and its content does not need to be sent by the server and rendered by the browser. But what if you need to update the majority of the page to display a different form of content? Well, let's explore that scenario. Suppose you are building a web application that has two pages. One page shows the latest news, and the other page shows the current user's profile page. A navigation bar at the top of the site contains a link to each page. In a traditional website, when the user clicks the profile link, the web browser sends the request to the web server. The web server generates the entire HTML page and sends it back to the web browser. The web browser then renders a new web page. In a single-page application, different pages are broken into templates, also known as views. Each view will have HTML code that can be updated by the application. For instance, the profile page would have a username, a first name, and a last name. The web browser sends the request to the web server, and the web server sends back a file called a JavaScript Object Notation or JSON object. This contains only the data to be displayed, such as a user's first name and last name, and the SPA will update the HTML. This is much smaller than sending an entire web page. The web browser then updates the web page by inserting the template with items replaced by the values in the JSON object. For your next website, consider whether its complexity suits a traditional multi-page application or would perform better as an SPA. Remember that a single-page application has two methods of delivering resources: delivering all resources immediately or delivering resources dynamically as required. If all resources are delivered when the application is loaded, the single-page application must include the views for every page on initial load. If resources are loaded dynamically, the single-page application requests the views as required and stores views in the browser for subsequent requests. Now you can compare some popular SPA websites to traditional ones and judge the performance difference for yourself. I'm sure you've created something from scratch before. I bet you realised how challenging it can be as opposed to using pre-made components. Think about the effort that goes into building a brand new house versus the convenience of constructing a modular building with pre-made components that you just need to put together. React is focused on working with components, which makes it simple to build functional user interfaces on web and mobile. And since React is one of the most popular JavaScript libraries, it's important that you can explain what its purpose is and describe how its components work together. Available since 2013, React is an open source library with a community of core contributors and companies that maintain it. Developers use React to develop single-page applications, and you can also develop mobile applications with React Native. When you develop an app, you can choose to use React to develop the user interface, but building an application requires more than that. You must also consider the navigation and how the app will request data from a web server. Therefore, React is used in conjunction with other JavaScript libraries during development. But what makes React so useful is that it allows developers to write less code to create functionality. This in turn makes it easier to maintain code in the long term and simplifies testing. Because it is so central to front-end development, there are many tools that you can use with React. These tools can help you understand how React is running your code and how you can improve performance. Now that you have a better idea of what React is, let me tell you more about React's components. The key concept behind React is that it allows you to define components that you can combine to build a web application. A component is basically a small piece of user interface, such as a music player or photo gallery. This component model allows you to do several things, such as developing and testing parts of their application in isolation, and it also allows you to reuse components across multiple sections of the application as well. Let's explore an example. Most web applications have user profiles with pictures. Normally, several parts of the application use a version of this profile picture, such as in the navigation bar beside the user's name. It could also show in a user search result along with several other user pictures. And the user picture might also display in instant message notifications. Instead of programming the logic for every instance of a user profile picture, React allows you to create a user icon component that displays a version of a profile picture every time it is used. You can then reuse this component throughout the application. Can you imagine how it will improve your efficiency? There are, in fact, many open source libraries that provide pre-made components for React projects. For example, if you want to add a video player to your website, there's a React component library for that. Or maybe you want to embed a map. There's a React component library for that too. As the React community grows bigger, it continues to add new features and improvements continuously. Annual React conferences encourage community sharing and introduce upcoming developments in the library. I hope that in the near future, you might be joining the React community as an active member. And as a future React community member, You now know the React library's purpose and how its components work together to make life easier for front-end developers. After all, why build something from scratch if the components are already there to use?
It's probably the coolest thing about React. You learn it once and you can write code almost anywhere. It's one of those ubiquitous technologies that if you're building user-facing products, React is a good bet. Take one and... Oh, I'm having fun now. I'm Benedict Hobart. I'm a front-end engineer at Meta. I think React was created at this time where we had a few other frameworks were sort of at the tipping point when people started taking web development seriously. There was a lot of excitement about writing JavaScript and using React to build apps, and the amount of momentum React created after it was open sourced, and later, once React Native came about, it was definitely at a time where web applications were becoming really complicated, and this UI library was necessary and to make apps actually work, because before then there was nebulous structure for a lot of products. There's an entire org at Meta building React. I'm on this team called React Apps, which is about 100 people, and there's a sister team called React Technologies. And then there's the supporting React Apps team, which sort of builds a lot of frameworks and that sort of thing to use React properly. So yeah, it's grown into a very large group of people supporting the technology at Meta. So there was a lot of imperative code needed in order to articulate how the UI should respond to user events. Where React was unique was that it took our views and made them a pure function of state. So I think that was the fundamental problem that makes React useful. And because it's component-based, it let you define your functions in a way that's easy to reason about and understand what will happen when certain events take place in the system. The sort of applications you'd write as a result of this became easier to reason about versus side effect driven. Things happening anywhere can lead to bugs anywhere. React sort of made it so like this one UI is driven by this input, which simplified things a lot. So there was a big drive to open source technologies in general. And I think the general push around open sourcing technologies is give back altruistically to the developers around the world that, aren't inventing these technologies, and also to get support from them. And I think with the React community that's what makes it so exciting, is that you have so many people in that community caring about how to best build apps, and they all support each other. We've seen, the rise of entire companies built around React. React's impact is massive. So many companies rely on it as a technology. I guess it means job security. I mean, lots of people are hiring for React. Learn JavaScript. Spend some time learning coding. Take it slow, especially if it's your first language. Try and get the foundations. It might take a while to click. It's sort of like a cliff. When you're learning programming, things take a while to click. And then when they do, the pieces fall into place, the jigsaw becomes clear, and you're like, oh, okay, this person isn't a wizard. They're building a house and they know how to use nails and wood, right? So take your time, go easy on yourself.
By now you've learned that you can build components in React to develop user interfaces. But how do React components turn into the elements on the web page that you see? Remember, when your web browser receives an HTML page, it constructs a document object model, or a DOM, to represent it. But updating the DOM is considered expensive because it is very time-intensive for the web browser to do so. Every time the browser DOM is updated, it causes the browser to recompute the page. Yet many big and popular websites still load in no time today. How can it be? In this video, I will explain how React solves the problem by computing its own virtual DOM. Let's start with how React components relate to the website displayed in your browser. A React component has a one-to-one relationship to an HTML element that is displayed on the web page. But how does React keep track of which HTML elements need to be updated? This is where React's virtual DOM comes into play. When React builds out its tree of components, it builds out its own DOM in memory called the virtual DOM. The virtual DOM is a representation of the browser DOM that is kept in memory. React uses this virtual DOM to update the browser DOM only when it needs to. This ensures that your application is fast and responsive to user input. Let me explain how it works. React checks to see if the HTML components in the virtual DOM matches the browser DOM. If a change is required, the browser DOM is updated. If nothing has changed, then no update is performed. This process is called reconciliation. Let's break down what happens when you update a component in React. Firstly, the virtual DOM is updated. Then React compares the virtual DOM to the previous version of the virtual DOM and determines which elements have changed. The changed elements and only those elements are updated in the browser DOM. Changes on the browser DOM cause the displayed web page to change. In this video, you've learned that React constructs and updates a virtual DOM so that the browser will only update certain HTML elements instead of recreating the entire page. Planning an application as a series of components can be tricky at first, but after doing it a few times, it'll become easier. You've already learned about the core internet technologies, and now you know that JavaScript libraries in React allow you to develop user interfaces much faster. Isn't it cool that you can develop user interfaces so quickly? In this video, you will learn how the component hierarchy works in React. Every React application contains at least one component, the root component or app component. Components are added to the app component to build out a tree structure of components that make up the application. Let's explore an example of how an application might be structured as components. Suppose your application is a shopping list of items that need to be picked up from the grocery store. At the root, we have the app component. The app component has two child components, new item bar and shopping list. The new item bar component allows us to add new items to the list. The shopping list component contains a shopping item child component for each item in the shopping list. Even though the item itself might be different, such as chicken or noodles, it is displayed in the same manner as other items. Therefore, you can reuse the shopping item component to display multiple items. When a user ticks off the items, the list will update and remove the corresponding shopping item child component from the shopping list component. Now that you understand the component hierarchy, let's explore how a website can be broken down into components. As an example, I will talk you through a typical blog website. Normally, there is a heading, a menu, and a search bar. You also usually have a featured blog post that displays larger than previous blog posts below it. Now, let's unpack the component hierarchy. At the root of the component hierarchy, you have the app component. This is the entire web page. The app component has two child components, the navbar component for the navigation bar and the page component. The navbar component contains the title of the blog, navigation links for the website, along with the search component. In the page component, we have three components, the main feature component and two instances of a small feature component. The main feature component displays a blog summary about a specific blog post. In the small feature component, there is a blog summary and a thumbnail component to display an image associated with the blog post. Notice that the small feature component is used twice. It is the same piece of code, but for the second small feature, the code uses different properties. And that is exactly the benefit of building a website with React components. You can reuse code for multiple sections. Using a series of components to build an application can be tricky at first, but after you do it a few times, you will appreciate how handy it is. Good luck with planning your component hierarchies in React.
Isn't it great when you have a device or process that can perform more than one task? For example, imagine that you own a grocery store in your hometown. You originally built your own website and your customers can place orders online. You know that these days, most of your customers use mobile devices and you want them to have access to your online store no matter what device they use. Often, applications are built separately for web and mobile devices, such as iOS and Android. But having two different teams maintaining two different code bases for iOS and Android devices would be expensive and inefficient. This is where React Native comes in. React Native can reduce the number of resources required to build mobile applications. Instead of creating two different versions of the same app, you can save time and money by building real native apps for iOS and Android using a common code base. In this video, you will learn about React Native and the benefits of a common code base. First, let me take you on a journey back to 2013, when React Native began its life as a hackathon project. Back then, if you wanted to develop a mobile version based on your app, you needed to wrap it in a component browser on the mobile device using specific third-party tools and software. While this worked, trying to emulate the look and feel of the native operating system still required different components and technologies. In the end, the user experience just wasn't the same as using an app specifically built for the operating system of that mobile device. The term native development refers to creating apps specifically for a single platform. So, this ambitious project aimed to achieve this native mobile development using the same web development features of React.js. The React.js library was gaining massive popularity in the web development world, especially for single-page applications. It allowed developers to create apps with powerful user interfaces that were fast and scalable. Unfortunately, if developers wanted a mobile version of that same app, development tended to be more challenging and needed more effort. At this time, mobile development was considered a more time-consuming process. Engineers wanted to create the React-like ecosystem of fast iterations and a one-team development workflow. There was a need to reduce the complexity associated with mobile development. These resources included multiple teams and technology stacks, which generally resulted in a slow turnaround. If you wanted to create a mobile application, you needed 2 development teams to build it for the 2 main operating systems, iOS and Android. The teams needed 2 different skill sets: development environments, operating systems, programming languages, and user interface elements. To sum it up, it was all just different. With 2 different development processes of the same app, updates also became problematic. If one operating system was updated, it would require an update to the mobile app, which would affect the other app running on a different operating system. As a result, 2 teams of developers were constantly back and forth, making changes for each platform. Using React Native, developers write a single codebase that can be exported to build web, iOS, and Android apps. It allows one team to build one application that will work seamlessly on both platforms using the built-in or platform-specific components and user interface elements. For example, React Native allows developers to use the mobile platform's built-in or native components, such as the camera, while using the same programming language. The team can now work in the same development environment and share the platform components while accessing a shared codebase. If an operating system of a mobile device gets an update, it's not an issue. The app is using the native components that have also just been updated. While this might seem like magic, it's actually just JavaScript. More specifically, a JavaScript framework that combines the best parts of native development with React. React Native developers have a saying: with React Native, one team can maintain 2 platforms and share common technology, React. In this video, you learned about React Native and the benefits of a common code base.
React Native is a framework that can power experiences on a multitude of platforms. You can learn the language, the framework, the tooling once, and you can create an iOS application, an Android application, or a virtual reality application, and even potentially future platforms that aren't around yet. Hi, I'm Eric Hartzog. I'm a software engineer at Meta, based out of Denver. I currently work on React Native, using it to help build applications for the Quest. So one of the biggest misconceptions that I often face is, as a React Native developer, people think that, oh, you're a front-end developer, your job is to change the color blue to the color red, and that's pretty much what you do. Well, there's actually a whole bunch to it, especially in a framework like React Native, where you're essentially compiling a native application for iOS, for Android, for the Meta Quest and VR. There's a lot of pieces that have to fit together, and so the front end just isn't about styling anymore. It's understanding how all the pieces fit together, and that's one of the things that I really enjoy doing, because it's a challenge every day, and there's always new platforms, there's always evolving platforms, and so the learning really never stops. So before React Native came around, if somebody wanted to create an application for iOS and also for Android, they needed to do it twice. A lot of times this meant 2 teams, one for iOS, one for Android. You could find devs who maybe knew both, but they weren't specialized in either, and so it'd be kind of a challenge to really have a polished app working in both. So the need for React Native came out of trying to deploy applications using web technologies onto mobile devices. There was a lot of problems with this, such as performance, touch interactions, camera access, all sorts of small issues which came up. Really what we needed was a way to build true native mobile applications. Back in 2012, there wasn't a lot of options for how to do this, so it was kind of a build your own road, figure out how to do it kind of thing. Facebook.com was transitioning to a mobile first focus. So they realized they needed to deploy mobile applications on iOS and Android. So when React Native was first created, it was kind of a brainstorm and which led to a hackathon. So a hackathon is a block of time where a developer can try out an idea that may not pan out. And that's okay because sometimes you don't know if something's going to work and you just need a chunk of time and you say, hey, this is going to take me a day, this is going to take me a week, or this might take me a month, and I want to try this idea. And React Native was one of these products. So it actually didn't start out as a full dedicated team. It was more of an idea that somebody had and that said, hey, Facebook created the React framework and it's been a great success on the web. Let's see if we can use this to create something for iOS and Android. They created it, they experimented with it, it was working, it was great. And so in the end, Facebook decided to dedicate a full team to React Native and proceed down that path. So fast forward to about 2015, they decided to make the decision to open source React Native. When the launch of React Native was first announced as open source technology, it was really exciting because people across the development world had already signed on to React. React was a great framework for building web applications, and it had a stable developer community that was really behind it. And so when React Native came around, all of a sudden, these developers with this skill set realized they could potentially use React Native and the knowledge they used from React to build an iOS and Android application. So all of a sudden, instead of just being a web developer, without going through too many steps, you can now be an iOS and an Android developer. And there was a lot of excitement about this because previously, you had different silos for different platforms. And if you were an iOS developer, you couldn't necessarily go into web or Android. But now you could have one developer switch back and forth between web, iOS, and Android whenever they needed and be able to build an application for that. And that was a big change in how we look at application development. So right now, my work is unique in that I am focused on building React Native applications for the Meta Quest in virtual reality. And if there's any place exciting to be right now, it's in virtual reality. So that's a new platform for which we don't have a lot of guides, a lot of how-tos. And so a lot of it is figuring out as you go. Luckily, we can bring this knowledge that we have from previous experience with React Native. So I've worked in iOS, I've worked in Android, I've worked with React on the web. All that experience, all that tooling, I can bring with me to VR now to help create VR experiences. And it's really exciting to be able to do that, to apply those lessons learned and to create really vibrant, interactive experiences in virtual reality using the tools that we're already familiar with. Now is a really good time to be learning React Native. The market has already proven that React Native is a success on iOS and Android. It's used by major corporations all over. There's a huge developer community around it. React Native is always changing because iOS and Androids are always changing. Our devices are always updating, and so it's not a static, stale platform. It's something there's always something new to learn, and it's always exciting to be in. So to help build confidence starting out with React Native, recognize that there is a vibrant, active community out there, and there's open source discussions and all sorts of ways to find the information that you're looking for to help you build your application. So whether that's looking at GitHub issues, starting your own, going into Discord chats to talk with developers or other people working on their own applications, go engage in discussion, go engage in the community, and be aware of the resources out there for that communication. I wish you luck in learning React Native, and I hope that building your first application is a lot of fun and you're able to get good feedback and experience with the React Native community.
You've reached the end of this module on React and React Native. Over the course of this module, you've explored the concepts of cross-platform development and the React and React Native languages. It's now time to recap the key lessons you learned and skills that you gained. You began the module with an introduction to cross-platform development. Following the completion of this first lesson, you can now explain the concept of cross-platform development in the context of iOS and Android mobile applications, identify best practices for developing cross-platform mobile applications, for example, adherence to high UI and UX standards, or the importance of debugging. And you can also outline the advantages and disadvantages of cross-platform mobile application development, like cost reduction, marketing, and integration. You also learned how to describe the concept of emulation, along with the importance of emulators. You can demonstrate how to use an emulator in order to debug an application, and you can identify the limits of emulators, like battery issues and display. The next lesson that you encountered was an introduction to React, the JavaScript library used by web developers for building user interfaces. By completing this lesson, you can now differentiate between static and dynamic web content and list examples of how each work. Explain what a single page application is, how it works, and how it differs from traditional web applications. Outline the purpose of React as a JavaScript library. Explain the concept of the React component model and identify examples of common components, and demonstrate a high-level understanding of React components. Now you can explain how they operate as a hierarchy in order to generate a web page through the virtual DOM. Following the React lesson, you were introduced to React Native, a JavaScript-based mobile app framework, which is used to construct natively rendered applications for iOS and Android. During this lesson, you learned how to demonstrate a high-level understanding of how React Native facilitates cross-platform mobile application development through JavaScript, identify the rationale for a common code base, and outline the benefits of a common code base such as cost, simplicity, and increased development speed. You're now familiar with the basics of React and React Native, along with concepts like cross-platform mobile and app development. Excellent, you've made great progress in your React Native journey. In this course, you got an introduction to mobile development. Let's do a brief recap of what you covered. In the first module, you covered mobile applications. You learned about web and mobile developer roles to find out what kinds of careers there are available in the field. The module featured an example to show what a day in the life of a mobile developer is like. Next, you learned more about web pages, web servers, and web browsers, and how they all work to make what we call the internet possible. You covered what happens when you send a request to look for something online, for example, and how that information gets back to you. Then you had an introduction to mobile development. You studied the evolution of mobile applications, the iOS and Android platforms, and the programming language developers use for each of them. In Module 2, you covered the three main web technologies: HTML, CSS, and JavaScript, and how they interact with each other. In HTML, you learned how to create an HTML document, how to use simple HTML tags, and how to link documents to create a website. And you covered techniques to improve web accessibility and some assistive technologies available to provide universal access to the internet. Next, you learned how to use CSS to style web pages. You explored how to select and style elements, use text, color, and alignment to make the web pages you create look great and offer a great user experience. Then you focused on JavaScript and found out why it's called the language of the web. You also learned about the differences between web browsers and mobile browsers and how responsive websites can adapt to multiple platforms and devices. You then covered some web browser tools that you can use in Google Chrome to help you code more efficiently. You learned what an IDE is and how it can help you speed up your work as you start writing code. You also explored some of the most common IDEs. In the third module, you learned about React and React Native. You explored how cross-platform mobile development enables you to build applications that are compatible with iOS and Android. You also covered the pros and cons of using this approach to create apps. And you learned how emulators use your computer hardware to replicate the environment needed to execute iOS or Android. Next, you cover the differences between static and dynamic content and how single-page applications feel faster and more responsive to the user than traditional web applications. You learned about the Document Object Model, or DOM, and how you can use it with JavaScript to query and update web pages. You also learned that you can use React to create components to develop user interfaces and how component hierarchy is built for an application. And you explored other JavaScript libraries commonly used with React. Then you focused on React Native and learned about the advantages and disadvantages of React Native development. Finally, you covered why Meta created React Native. Congratulations on reaching the end of this course on mobile development. You've worked hard to get here and developed a lot of new skills along the way. You now have a great foundation for mobile development with React and React Native. And you've also demonstrated your skill set with React Native by creating and styling your first web page in the graded assessment. You can now demonstrate knowledge in cross-platform mobile development, show familiarity with React and React Native, and demonstrate skills with mobile application development. And the key skills measured in the lab revealed your ability to demonstrate knowledge of key concepts around web and mobile development, exhibit an understanding of HTML, CSS, and developer tools, and show a working knowledge of React and React Native. So what are the next steps? Well, this is the first course in the React Native specialization, which means that while you've established a good foundation so far, there's still more for you to learn. Throughout the next courses of this specialization, you'll continue to develop your skill set. In the final course of this specialization, you'll then bring together all the skills that you've learned and create your own fully functional mobile app using React Native. Whether you're just starting out as a technical professional, a student, or a business user, this project will prove your knowledge in the value and capabilities of React and React Native. You'll have a working mobile app that you can include within your portfolio to demonstrate your skills to potential employers. And not only does it show employers that you're self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. And once you've completed all the courses in this specialization, you'll receive a certification in React Native. It's been a pleasure to embark on this journey of discovery with you. Best of luck for the future. Hope to see you again soon.